Hi everyone, and welcome to the channel. So the project on the bench today is this Hewlett-Packard 6114A Precision DC power supply. So I came across this power supply just being sold in untested and unknown condition, but the price was too good to pass up, and quality HP equipment like this is always welcome on the bench. So let's take a closer look and see what it takes to put this power supply back into working condition. I've already tried to power it up, and I did notice a couple issues going on. So I'll show you those in just a moment. Now for the age of the power supply, it looks to be in nice condition. There's a few minor scuffs in the paint, nothing too serious, so it doesn't look like it was dropped or abused in some way. Now on the front panel, you can see for setting the voltage, you have these push button switches right here. So this looks to be a digital sort of selection for the voltage, but this power supply actually uses only analog circuitry. There's no digital logic, no microprocessor. So for example, if you wanted to set 1 volt, you would just press that button right there and it's 1.00, and then this would be millivolts here, which is turned down to 0. So if you wanted to go back around, you could go that direction as well. That would be 9 volts. If you wanted 10 volts, it'd be like that. So very easy to set the voltage. 100 millivolts would be like that. Now over here you have a selector for the meter for volts or amps, so you can see the two scales on the meter. Now obviously with this meter and the way that the tick marks are and the values on that scale, for voltage, if you had that set to 100 millivolts, you're basically not going to see any movement on the meter. So this is just for confirmation that you are getting some voltage, but it's not going to show the very fine values down here. You would just trust that the meter is accurate or use an external meter to monitor. Now right here, for overvoltage, this LED comes on if it does go into the overvoltage, and there's a setting right here. Current adjustment for constant current mode, and if it's in constant current mode, that LED turns on. Now the numbers on this dial right here, and this is a multi-turn dial, so you can see the outer ring counts the number of turns. It goes all the way up to the maximum right there. The dial on here doesn't seem to be related to the actual current value, so you're not, the numbers on here don't mean anything, they're just an arbitrary value. Of course the line switch on and off, power indicator right there, neon indicator. And the output terminals here, there are output terminals on the back panel as well. Now right here, this terminal with the black ring on the front is just chassis ground. These are the two outputs. You have the positive and the negative. And Hewlett-Packard often did this where the negative has this red ring on the front as well as the positive right here. I'm not a big fan of that, but they did that on a lot of their equipment. In a previous video, I repaired a Hewlett-Packard 66312A DC power supply, and one of the binding posts on the front was damaged. And when I had it apart, I replaced the negative terminal that had the red ring with a black ring. I'm just not a big fan of having both of these with the red. It's so common to see black and think that's the negative output. So you have to watch this. The markings, of course, are just above the terminals. But this is not a dual rail power supply. Don't be confused with these 3 outputs like this, or 3 terminals, I should say. It's just a single output. Again, this is just chassis ground. So in normal use, you really aren't even connecting over here. And if I turn the power supply around, you see the back panel, really nothing too interesting going on back here, but there's a cover right here, 2 screws. I've already taken that off. There's 2 terminal boards under here. They have some jumpers tying different terminals together. I've checked, those are set correctly for local operation, so there's remote voltage sensing and other ways that this can be configured, but everything is set up just for normal local use on the front panel, and again, local voltage sensing. AC line cord plugs in down here, and there's a fuse. I checked the fuse, it's correct, no problems there. So a little tag on the side right here, it's very faint, but it looks like it's, well, it does say option, I can make that out, but it looks like the number is 015 or maybe option 15. I'll have to take a look and see what that means. I don't know exactly what option 15 would have been, and I think that's the number on there. It's very, very faint. All right, so let me get the power cord here. I'll power this thing up. And what I will do is just bring this meter over here as well so you can see that. Like that, make sure everything is in the shot here. Over just a little closer so you can see all of it. So disregard the numbers on there right now. It doesn't mean anything. It's just some floating voltage or something in there. This is microvolts anyways, this is millivolts, that's microvolts, a very low value that it's showing. All right, so get the AC line switched on there, and here we go. So it turns on, we have power on indication right there. And right here, let's just say we go to 10 volts, and that's normal, so we have 10 volts over there. Now, I'm sure this needs some calibration, maybe to dial things in a little closer. It's sitting what should be 10 volts, and it's about 7 millivolts high right now. Also, this needs to warm up and stabilize, and of course, I'm just turning it on right now, so it hasn't had a chance to warm up. But the indication right here, it's right at the 10 volt tick mark, and again, very, very close on that digital multimeter. And that Keysight digital multimeter is under a factory calibration. It's known to be very, very accurate. So you know, right now it looks like everything's working okay. But if I go over here, and sometimes when I turn this on, the fault happens right away. In this case, it did turn on the way that it was supposed to. Now the overvoltage adjustment in here, just take a little screwdriver and you can reach in, and it's turned all the way to the maximum right now. So if I reach into the slot right there, see, I can't turn it, and you see it happened, it actually just went to overvoltage. But I can't turn it any further clockwise, so it's at its maximum, which should be above 40 volts. But basically just wiggling that a little bit, it didn't turn because, again, it's already at its maximum rotation. It went into overvoltage, and it shuts the output off, and the power supply, you know, everything shuts down. So the only way to reset that is to turn the power supply off. Now, if I turn this like this, and you can see I can rotate that all the way around, so there's minimum right there. That would be the lowest overvoltage setting. So I'm all the way back up. Okay, there it's at its maximum again. It went into overvoltage right away. So it's clearly a problem because overvoltage shouldn't be happening when that's at its maximum. And then this is sitting right there, you know, at just 10 volts. That's not correct. So if I reset that, let's try again. See, 10 volts, now it's okay. So it seems very unstable with the overvoltage. Now it's possible that this potentiometer is dirty. Oh, it just went into overvoltage all of a sudden, so a little bit random as well. But it's possible that the potentiometer is just dirty and needs to be cleaned, or maybe it's damaged somehow, or maybe there's a problem with the overvoltage circuit. Now, my first bet is that the potentiometer needs to be cleaned in here, and that's the first thing to certainly try, and the easiest thing to do. So, you know, that'll be the first step. But I've already gone like this and turned this back and forth like this a number of times, and it hasn't made any difference. And usually if you have a potentiometer that's very dirty, just rotating it back and forth like that without even putting some cleaner into it can help it improve maybe just a little bit. In this case, it really hasn't changed anything. It's still really touchy and, you know, just seems to be very random. And I really can't find any point that seems to make sense. You know, you can turn it halfway and it still trips at 10 volts. Other times you set it halfway and you can go up, you know, even higher. So it seems to be all over the place. So definitely an issue going on there. Now the other thing is, okay, it's going to work there, so we'll just leave that alone. So it's at 10 volts right now. But this switch right here for volts and amps, so if I go like that, you know, that goes over to the amp position. This is sitting at 0. There is no current right now. What I will do is, let me just go over here. Actually, I'm going to turn that off for a second. Let's just move this over to the current setting right here. DC amps. Okay. And put that on the 10 amp setting. So essentially this is making a short circuit, but this will go into constant current mode, so it won't hurt the power supply, and we'll be able to see the current measurement over there, and it should match the meter over here. So I'll set that down to 0, turn that on. So it's not an overvoltage, so it's cooperating for the moment. Okay, there we go. So you can see right now it's indicating almost 2 amps there, just about 2 amps over there. I'll turn this up a little bit higher. So very precise control on the current. Looks good there, so right at 2 amps. And if I look straight on this meter, it's right at the 2.0 tick mark, maybe just a touch under, but very, very close, certainly within reason. I don't think that's any kind of a problem there. But if I go like this and I put this back to voltage, now it's indicating a very low value because it's in constant current mode and the voltage has dropped very low. But if I move this back over again, and of course it's cooperating right now, but it seems to be okay. Let me see if I can do this. This switch actually has improved with use. You can see how it's moving around a little bit there. It wasn't real steady. Okay, there it did it. It's in amps and it's not moving at all now. And that's what it was doing when I first powered the power supply. It basically wouldn't work at all for indicating amperage. So there's definitely an issue going on with this switch. It needs to be cleaned up, I would imagine, unless there's a wire that has come loose or something like that. But it's probably just that the switch contacts have become dirty. So again, some cleaning in there is probably necessary. And it works again there. So sometimes when it's in the amps position, it'll start to fluctuate. And the actual current never fluctuates. It's very steady, but the reading over here will fluctuate around. And obviously that's just some intermittent connection going on. So 2 issues here, need to take a closer look. So let me get this thing opened up and we'll take a look inside and see what we can do about these problems. And I'm going to turn off the AC line, unplug that, grab my screwdriver, it's over here. So start taking some covers off here, see what we're dealing with inside. All right, with that, all the covers are off and we are into the instrument here. So let's take a look. So the power supply looks pretty clean inside. A little bit of dust and build up on the power supply on the circuit board, but it's really not too excessive. Definitely seen a lot worse, so it doesn't look too bad. Just a mild cleanup on that board. I'll have that looking pretty good. Very large heat sink here on the back. Some power transistors I can see down there. Looks to be in good condition though. I don't see any components on this top side that are damaged or overheated. No evidence of leaking capacitors. So I'll go through and I'll check these capacitors, make sure that they're in good working order. They're measuring okay. Now I've looked at the service manual already and looked over the schematic and have just kind of a general idea of where things are located. But this board right here is the main voltage reference board. Calibration potentiometers across the top edge right there. Looks like these components here, looking for date codes, 81, perhaps 1981. That transistor and maybe on that resistor right there. So maybe around 1981. Look at those massive capacitors. Very large filter caps right there. Pretty stout transformer too for a 2 amp power supply. A lot of iron in the core of this transformer there. It's definitely top quality, typical of what you'd find with HP. So yeah, everything looks good inside. I mean, at first glance, I'm not really seeing anything that stands out as a problem, just in the way that it looks. So I think the first thing to do is to try and clean this potentiometer and this switch, and I can access that probably from this corner right here. So I will use, let's see here, this product works very well, so I'll probably use this for both the potentiometer and the switch. I've had very good luck with this product. And in no way are they a sponsor for the channel. It's just a product that I personally like to use, and again find that it works very well. When you're cleaning potentiometers and switches, you never want to use something like just a contact cleaner that would strip out the lubrication that you need, particularly on a potentiometer, because if you do that, the potentiometer will be very dry and the resistance track will end up wearing out. So you always want to use something like this that's intended for potentiometers and for switches, because this has a lubricant in it as well as a cleaner. So I'll use that cleaner off camera. I'll work through that, clean that up a little bit there. I'll clean up this board, and then let's power this back up and see if there's any improvement. If there is, great, we're well on the way to getting this back to working. If there's no improvement, then there's going to be some electrical troubleshooting. So let's see what happens. Let's see if the potentiometer and the switch are working the way they're supposed to now that they've been cleaned. Now, of course, this is an AC line operated device, and necessarily it's being powered with the covers removed for the repairs. So if you're following along and you're working on a power supply like this, you're definitely doing so at your own risk. So take care and be safe. You always need to use an isolation transformer when you're working on something like this. If you're not familiar with an isolation transformer, and also using a variac and an incandescent lamp for current limiting. In this case, I'm not using an incandescent lamp or a variac. This is just powered off of my isolation transformer. But I did a video quite a while back about an isolation transformer along with a variac and the incandescent lamp, also known as a dim bulb tester. So definitely check out that video if you're interested in setting up something like that on your own bench and doing these types of repairs. And I also show in that video the type of setup that I have on my own bench. And you might be thinking, well, what's the shock hazard if you're just working on the front panel here? Well, there's AC line right on the back of this switch. If you're handling the power supply, your finger comes underneath here and touches on the back side of the panel. Maybe you're turning things over a little bit, just angling things differently. You could easily get a shock right on the back side of the panel. It's exposed right on the back of that switch. So again, if you're working on something like this, take care and be safe. All right, so let's power this on. All right, so it did not go into overvoltage protection, so that's good to see. So let me just reach in here. So this is all the way turned to the maximum clockwise. All right, so that's good to see as well. It's not tripping like it did before. So I'll leave that set all the way to the maximum setting. So this should be able to go to the maximum output and not trip that. So let's try that. Go here to 3999, turn this all the way up. Okay, so that's essentially 40 volts, as high as it can go. And it didn't trip, so that's good to see. Now let's try this. Let's go down. So I'm going to go counterclockwise very slowly. Okay, right there. So that tripped, so that was just a little bit of an adjustment backwards. So now let's turn that off, so that resets it. And let's try this way here. Let's set this to zeros. So I'll leave this at now 39 volts. So it's almost 1 volt lower than it was before. Okay, so it didn't trip. That's good to see. So let's increase this. 39.5. Oh, there it tripped. Okay, perfect. Great, that's good to see. So it looks like it's stable in where the setting is at. Seems to be quite accurate. All right, so let's turn this back off again, and let's see if about halfway would be about 20 volts. So let's try, go down, let's go here, go down to say 18, I'll go down to 15 just to start with. Turn that all the way down. Okay, let's try 15, and I'm going to put this roughly in the halfway setting. So there's a slot that I can see looking into this hole right here. So if I go from that extreme to that extreme, right about there, looks like about halfway. All right, so let's turn this on. Okay, didn't trip. 16, 17, 18, 19, and I have to go to 20 like that. 21, perfect. So 20 would be half. So the range on this and the travel from the two extremes looks to be correct now. So I think this is repaired. I think it's working the way it's supposed to. So let's go back down here. Let's go to that, go to 10 volts, turn that off to reset it. Let's go back to the maximum. Let's see if this switch is working now. So I'm going to reach over here and just grab a test lead of the digital multimeter. So I'll plug this in. This will just go to the constant current mode. All right, let's try this. Okay, so 2 amps. Just no problems there. So of course voltage is very low because it's in the constant current mode, and this is basically just a direct short, so very low voltage across the output right now. So yeah, every time I go to the amp setting, it seems to go right to the 2 amp reading. Doesn't seem to fluctuate around. If I wiggle the switch, it seems to remain steady. Great. I think that switch is working the way that it should now. Doesn't seem to have any intermittent connection. Take that back off again. So voltage 10 volts, perfect. 20 volts. Great, looks like it's okay, both positions. So I think really just, dirty contacts and a dirty wiper and resistance track in that potentiometer is probably the issue that was going on there. To clean that potentiometer, I just sprayed that cleaner in there, worked it back and forth a dozen times or so, rinsed it with some more cleaner. And basically the same with the switch, a little shot of the cleaner in there, worked it back and forth a number of times. So I cleaned inside the power supply. I used a soft anti-static brush and some compressed air, just to remove the dust on the circuit board and around inside the chassis. So everything looks very nice inside the power supply at this point. Now I also removed this circuit board, and it plugs in this connector, and these are gold-plated contacts inside the connector and on the edge of the board. I noticed kind of a scum or buildup on those contacts. That's been cleaned up as well. But I also noticed an issue going on with the way this board is mounted in here. So this screw and the standoff and so forth, same thing over here with this hardware, it goes on each corner of the board. So with that removed, of course, the board wiggles around in here. But if I take one of these screws and just go in here like this. So the problem is that the screw doesn't fit in straight like this. It's angled just a little bit. And the reason is the hole in this side rail and the hole in the board are not in line with each other. They're offset like that. And what happens is when the hardware is tightened up, it causes the corner of this board to flex a little bit. And of course, that's not good for the board. It could end up cracking a solder or damaging a component. There's some glass-bodied diodes right in that corner. Some strain on those could easily cause a problem. Now, this has probably been like this since it left the factory, but it definitely needs to be taken care of. So, of course, I was looking around to see, is there some way that things can be adjusted and make this line up a little bit better? But I really don't see any way to do that. So this board, of course, plugs into this board, so that's very fixed and rigid at that point. This board is mounted to this bracket, and I took some of these screws out, and there's not an elongated hole on any of those screws, so this is very fixed in how it mounts in here. And then this bracket is, attached to the side rail and other points inside the chassis, and everything, again, is very fixed and rigid. It's not adjustable. So I really don't see any kind of an adjustment, and nothing's bent or damaged. So, again, I think it left the factory this way. Just maybe a little bit of an oversight by Hewlett-Packard in getting things to line up here a little bit better. So if I go like this, take this out, and zoom in a little bit closer here, you can see the issue, what's happening here. So again, with this screw right here, this is where it wants to be, like that. So essentially that's making a 90 degree like that, okay, from this rail over to the screw. And you can see that that hole should be elongated over to the left just a little bit. So with it like that, you can see the screw is angled over that way too far, like that. So again, easy fix by just elongating the hole in the board. Now I don't like drilling on circuit boards. Luckily there are no traces nearby, so that shouldn't be any kind of a problem. The same thing on the other corner. I'd rather drill in the side channel over here on the rail, but I can't do that because these are countersunk holes, so I can't elongate that. It won't work correctly. The screw won't fit correctly, so I'll have to drill the board out just a little bit. So I'll do that next. Both holes are elongated, and now the circuit board fits much better. So you can see how the screw fits in here straight. It's no longer angled. Same with this screw. Corners of the boards aren't being torqued over. So the hardware is tight, and you can see the board is very secure. Also, I had to add a small fiber washer right there and also right here, although the real issue was going on right here, but if I added a fiber washer in one location, it had to be added to the other place as well, just to keep the board in here so it wasn't being torqued one way or the other. But the problem over here was that this metal standoff wanted to short against one of the traces on the board now that this hole had been elongated this direction. So this fiber washer will just insulate, keep that short circuit from happening. Now from the factory there was already a fiber washer on this other side of the board under the nut. So this is the exact same type of fiber washer. It worked very well. Earlier in the video I mentioned that this power supply has a tag marked with option 015 or option 15. But it's very faint and hard to read. I took another look at that tag, and I really can't make out the numbers to be anything other than 015. So I was looking in the service manual, and it does list 4 options, but oddly option 15 isn't one of them. So as you can see, there's an option 8, 13, 14, and 40. Now this power supply has the 10-turn current control potentiometer, and that actually matches with the description for option 8. So I'm not really sure what was going on with the option 15, but if anyone has documentation on this power supply that mentions an option 15, please leave that in the comments. I'd be curious what that was about. It's possible it was a custom option. Hewlett-Packard was known to do that on equipment. They do a custom build on something and it gets a special option number, although sometimes special options started with the letter H. Now, this power supply seems to be date codes around 1981 or so from what I'm seeing, and the manual that I'm using is dated from 1970 or 71, so there's nearly a decade difference. So who knows what happened in that time frame, and maybe this options, they changed the numbering or something like that. It's really hard to say. So a little bit of a mystery at this point. So I started looking at the calibration on the power supply, and the first thing that they have you do is to zero the meter. So you warm up the power supply, bring it up to operating temperature, and then turn everything off. And then right here, there's sort of like a little adjustment right under the window. There's a little kind of a half moon shaped area there. And you just take a sharp object and poke into the little hole there and move that back and forth. And it just brings the needle right to the 0 tick mark. So I did that. It was off by just a little bit, not too far, but now it's right on the 0 tick mark, especially when you look straight on. It may not appear that way on the camera, but anyway, that's taken care of now. And then moving through the calibration, and I haven't completed all of the calibration yet. I've just gotten started on it. But they have you go through and they do the gross current limit. So you set this to a maximum output voltage, and then the current should gross limit at 1.2 amps, even though this is rated up to 1 amp at the highest voltage levels. Again, gross current limit is 1.2 amps. And that was spot on. I didn't see any problems going on there, so I left that adjustment alone. And then moving on through some more adjustments and calibrations, they have you do the 0 output voltage adjust. And I had noticed that this was not sitting at 0 volts when this was all, right at 0, and the output was floating up to a value a little bit higher, and it was kind of throwing off some of the fine adjustments over here, which should be just in 1 millivolt steps. It really was off by more than you'd want to see. So on the 0 output adjustment, there's a jumper wire that you put on the back panel, so it's back on the back panel between the heatsink fins back there. So that's in place right now, and then it's actually from A1 to sense minus on the terminal board. But then you adjust assembly number 2 R13, that's this potentiometer right there, and you adjust that for a reading of minus 450 microvolts plus minus 50 microvolts. Well, check it out, minus 448 microvolts. So spot on, right within the range that you want to see. And it's been very stable now for, I'd say about 15 or 20 minutes. It's not drifting around or changing much other than a microvolt or two, but no significant changes. And the power supply has been on for over an hour. So it looks very good. Not seeing any problems there at this point with that calibration. So I'm going to remove this jumper wire back here. The purpose of the jumper is to disable the voltage control circuit. So let me just get that off of there. All right, so now it's back to the normal control, and the output is sitting at 282 microvolts. Excellent. So that's much lower than it was before. Essentially it's 0, so that looks very good. So let's try, let's say 1 volt. Awesome, look at that. So this is 1.00 and this is turned down to 0. It matches. So in a case like this, you can't expect these digits to fall to 0 because that's beyond the control of what this power supply could do. So it is sitting right within the same value, that this is adjusted to. So that looks good. 1.1, yep. 1.11, yes. If I go all the way, well, let's start here. First of all, I'll go about 0.5. Perfect, look at that. So that's on 5, so 1.115. That matches. Go all the way to 10, and yes, it does. It trips over. So when this is at 10, you would add 10, and it's perfect. That 1 carries over, so 1.2. Awesome. So that's working very well. Go to 10 volts. Oh, look at that. That's very accurate. How cool is that? It looks great. .111. Spot on. Yeah, no problems at all. So I'll keep going through the calibration, and there's a number of other steps I need to continue on with, and if I notice anything else that it's kind of out of adjustment or has any issues, I'll definitely include that in the video. So moving along with the calibration, one of the steps is to adjust the voltmeter. So on assembly number 1, it's R22, and you're supposed to adjust for full voltage output, and the meter should read within a plus minus 2%. And I had noticed that this meter was reading off by just a little bit, but I made that adjustment, and now check it out. So we go to 10 volts, spot on, right on 10 volts. 20 volts, no problem. 30 volts, perfect. And to go to 40 volts, just have to go to 39,999. And all the way up. Perfect, right on 40 volts. So the voltmeter is very accurate now. So continuing with the calibration, this is a zero output current adjust. So what you're supposed to do is turn on the power supply and set it for 2 volts. So I've done that. And then on the back panel, you're supposed to turn off the current control by connecting a jumper from position A6 to the positive output. So I have that jumper in place. And this is where I'm doing things a little bit different from what's described, but the end result will be the same. So you're supposed to connect a 0.1 ohm plus minus 0.1% resistor across the output terminal, so a very low value precision resistor. Although a little bit later on it says to use a 1 ohm resistor, and I think it's a typo, I think the decimal point fell off. What you're supposed to do is across that 0.1 ohm resistor, use a differential voltmeter and make the adjustment for a plus minus 10 microvolts across that resistor. So if you use Ohm's law, then you would know the current flowing through that resistor, and essentially you're adjusting for a very, very low value. Because I don't have that very precision type of resistor and that very low value, what I'm doing is just measuring the output current directly on the digital multimeter. Well, if you use Ohm's law, 0.1 ohms and 10 microvolts, so a plus minus 10 microvolts is what they specify, so the current could be negative. But again, 0.1 ohms and 10 microvolts is equivalent to 100 microamps. Well, check it out. I've made the adjustment already, and look at this. We're well within that spec. That's just 1 microamp, a negative 1 microamp. But that's fantastic. So again, the range would actually be a plus minus 100 microamps. So I'm very happy with the result. And the actual adjustment that you make inside the power supply, assembly number 2, it's R12. So yeah, I made that adjustment and it dialed right in. But it was a ways off. It was not near this value when I started. So essentially, the current control is turned off, which means that this adjustment has no effect at this point. And this is the lowest current. Basically, the output is turned off at this point. And a little bit of current flows, but it's very, very small, and that's what you're adjusting for. So when you turn that adjustment R12, you'll find that this value goes from a higher value and basically drops down to the lowest that you can get, and then it rises back up. So it goes from a positive down near 0, comes back up to a negative again. So again, this is essentially sitting at very, very low current, down into nanoamps, 1 microamp there. So I'm very happy with that result. Alright, so at this point the calibration is complete. Everything's dialed in and looking very good. So the final step is the amp meter calibration. It turned out very accurate as well. So you can see the digital multimeter is in the current measuring mode. It's just connected across the output terminals. And if I go like this and start turning the current up, so right there, so that's right at the 0.4 tick mark, and check that out, 0.4. Perfect. If I go up here, 0.8. Right there, right on 0.8, very accurate. Up to 1.2 amps. Right there, perfect. 1.2, essentially 1.2. Right at 1.6, looks like right about there. Perfect, 1.6, right on 1.6. And go all the way to 2 amps. And spot on, right at 2 and 2 amps. Excellent, looks very good. So the repairs and calibration on this HP 6114A Precision DC power supply are now complete. Very happy how it turned out. I'm definitely looking forward to using it on the bench. not only is just a standalone DC power supply, it has a very stable and accurate output and nice usable current range, and it's very easy to set up and use. So just as a standalone DC power supply, I think it'll be very useful. But it can also be used as a calibration source as long as what you're calibrating falls within the standards and tolerances of this power supply. And another way this supply can be used is to control some other devices. So for example, I have several dyno loads. A couple of them are an analog type control and several are digital control. But all of those dyno loads, which are electronic loads, have a modulation input. So for example, on the DLP 5060-1000A, that's an analog input, it has knobs on the front panel. But if you use the modulation input, which can come from this power supply, so the modulation input doesn't have to be changing, it can be a fixed DC signal. But by controlling it with this HP6114A, now that dyno load has a very accurate and stable load that it applies, or a current that it would draw from whatever you're testing. It could be a battery or a power supply, something like that. So again, the knobs on the front panel only allow so much accuracy, but the accuracy of this power supply is extremely precise, and you can just dial in on the front panel of the 6114A, whatever value that you want, and the dyno load will draw that current. Now, I have some dyno loads that have digital control, but they also accept a modulation input, and this power supply can control them. And it's still useful because those dyno loads can be off to the side or around the corner on a shelf, and then this power supply is almost like a remote control, and just two wires go from the power supply over to the dyno load, and you can just dial in what you want on the front panel of this power supply, and the dyno load will draw the current that you're setting it to. So again, very, very useful. Now, another way that this can be used is the 6114A can control a power supply like my HP 6269B. Now, the 6269B is a 0 to 40 volt up to 50 amps, but it has knobs to set the current and the voltage. So it has a constant current mode or constant voltage mode. And this power supply can be used to control either the constant current or the constant voltage. For example, if you're using it in the constant voltage mode, this power supply will set the voltage output of the 6269B with the stability and the accuracy that this 6114A has, but now you have up to 50 amps of current capability. So it's like taking this 6114A and increasing its current up to 50 amps. So that's pretty cool to have a very stable and accurate power supply, but up to 50 amps of current. So I think that'll be very useful to use it that way as well. So if you enjoyed this video, you can let me know by giving it a thumbs up. And if you're enjoying the content on this channel, don't forget to subscribe because there'll be many more videos coming up in the near future. There's a lot of projects in the queue. You won't want to miss any of those. Don't forget to tap the bell symbol to be notified when I do post a new video. And as always, thank you for taking time to watch. And until next time, take care. Goodbye for now.